I welcome you all to this 4-week course on analog electronic circuits, week 3, lecture 1. So far we have seen the frequency response of RC coupled BJT amplifier. In continuation, we see the RC coupled FET amplifier. So single stage JFET RC coupled amplifier. So because here source resistance is there, we represented here it as RV. Vs source voltage, coupling capacitor, source bypass capacitance. So similar and equivalent analysis can be done for this configuration. So we have seen in the week 1 the high frequency equivalent model of FET. Simplified model will be replaced in the place of FET and other equivalent circuit. Similar thing, external capacitors in combination with external resistors forms a high pass filter. The internal capacitors with other resistors forms a low pass filtering action. Similar analysis. So this diagram we have seen in the week 1 session. This is the equivalent of FET configuration. Vs RV coupling capacitor. Rg is nothing but R1 parallel R2. C1 is CGS plus CGD into 1 plus GM RL dash. Then RS parallel with CS. Then dependent current source GM VGS. C2 is the CDS plus CGD. RD, small rd is the drain resistance. Then the external resistor RD, coupling capacitor with load resistor. So here a different analysis I want to show here. So first we'll consider the effect of coupling capacitor at the input side. So the equivalent circuit is RV, coupling capacitor, it is with RG. So from this, I'll calculate the F11, the cutoff frequency. It is this capacitor in series with the resistor forms high pass filtering action. So F11, the lower cutoff frequency F11. Always the cutoff frequency is 1 by 2 pi R into C. Here the R is RV plus RG multiplied by CC. Without doing much of mathematical calculation, we can also give the equation for the cutoff frequencies. Similarly, F12 is output side coupling capacitor. So I'm taking the circuit G1 VGS, CD, RD, RD, CC, RL. So the circuit is GM VGS, RD, parallel with the capital RD, then CC and RL. So here the resistance is RD plus RD. This is Thevenin's equivalent circuit. This is a Thevenin's equivalent circuit. Again, replace it with a Norton's equivalent circuit. RD plus RD is the resistance, will become series. So F12 is 1 by 2 pi CC RD plus RD plus RL. Next calculation. And this is again the high pass filter. Capacitor in series with the resistor, we are taking the output across the load resistor. So it is again a high pass filter. F12. F13, the equivalent circuit is this combination. This combination is the coupling source bypass capacitance. The circuit is GMVGS parallel with RD, RS, CS, RD parallel with RL. These two combination RD parallel with RL. So here F13 is equal to, we'll derive this equation 1 plus mu 2 pi CS, 2 pi CS, then RD plus RL plus RD. This is a dependent current source parallel with the resistor replaced with a voltage source in series with the resistor. So RD in series with RD plus RD parallel RL multiplied by CS. Combination RS will be neglected. So this is F13. So as usual discussion F1, the three high pass filters F11, F12, F13. So F1 will be the max of F11 comma F12 comma F13. Similarly, the low pass filtering action because of internal capacitors. So we'll take the diagram. We'll neglect this coupling capacitor. So RV, RG in series with C1. In series with C1. So that combination will becomes F21 is equal to 1 by 2 pi C1. RG parallel with RV. Because the two resistors are parallel. So RG parallel with RV. That is F2. Overall F2 will be minimum of F21 and F22. Minimum of F21 comma F22. So F22 formula is output side capacitance, output side GMVGS, C2, RD, RD, RL. So this is taken here. All these three capacitors are parallel with the capacitor. So F22 is equal to 1 by 2 pi C2 capital RL dash. RL dash is parallel combination of small r, capital RD and load resistor. And the mid-frequency voltage gain is minus GMRL dash. So without doing most of the calculation, we have taken here the formulas for lower cutoff frequency and upper cutoff frequency. In continuation, you will see the case 1, mid-frequency case. So we consider internal capacitors open circuit, external capacitors short circuit, and consider equivalent diagram RVVS, RG, GMVGS, RD, capital RD, RL. These three parallel RL dash. V naught is the load current flowing through this combination of load resistor RL dash. So RL dash, we can make a substitution. IL is equal to opposite direction minus GM VGS. And VGS is the voltage across the RG resistor. So VGS is equal to VS into RG multiplied by RG divided by RG plus RV. And in general, RG value is very high in the order of 1 mega ohm. RV is the source resistance of a voltage source. It will be a very small value. So almost RG plus RV is RG. So RG and RG plus RV gets cancelled. VGS is equal to PS. So making a substitution here. So we are discussed, we are eliminated this in the last part. So V naught is equal to minus GM Vs into RG by RG plus RV into RL dash. So overall, mid frequency voltage gain is minus GM RL dash. This parameter is neglected because RV is a very small value. RG is 1 mega ohm, RG is 1 mega ohm, RV is in the order of 100 ohms. Next, case 2 is a high frequency case. Consider the effect of internal capacitors. Assume all external capacitors are short circuit. So RV, VS, RG parallel with the C1, GM, VGS parallel with the C2, RL dash, taking the output across V0. I'm considering this capacitor, the parallel combination of RG and C1 as Z1, RL dash C2 as Z2. And we'll continue the calculation. V naught is equal to minus GM base GM VGS into Z2. Z2 is the parallel combination RL dash by 1 plus J omega C2 RL dash. Substituting Z2 in this equation, that is V naught is equal to minus GM VGS RL dash divided by 1 plus J omega C2 RL dash. Z1 is equal to RG by 1 plus J omega C1 RG. So VGS is equal to VS. So see here, VGS is the voltage across the parallel combination of Z1. So Vs into Z1 by RV plus Z1. Vs into Z1 plus substituting the same RG by 1 plus J omega C1 R suffix G divided by RV plus RG by 1 plus J omega C1 RG. Making a substitution. Numerator part and denominator part and gets cancelled this part. The remaining equation is VGS is equal to Vs into RG. Denominator part RG plus RV plus J omega C1 RG RV. We are making denominator RG plus RV is taken common. two numerator part, that is Vs is equal to Rg by Rg plus Rv by 1 plus j omega C1 Rg Rv divided by Rg plus Rv. And this equation looks like a parallel combination of Rg and Rv. So I take it Rg and Rv. This is VGS. We'll make the substitution VGS in this equation. Make substitution in this equation. So which becomes V naught is equal to minus Gm by Vs, sorry, minus Gm into Vs by 1 plus j omega C1 Rg parallel Rv multiplied by RL dash 1 by, sorry, RL dash by 1 plus j omega C2 RL dash. So high frequency voltage gain is equal to minus Gm RL dash Vs here 1 plus j F by F21 F by F22. So where F21 is equal to 1 by 2 by C1 Rg plus Rg parallel Rv. C1 is equal to CGS plus CGD into 1 plus GF RL dash. F22 is 1 by 2 by C2 RL dash. C2 is equal to CGD plus CDS. RL dash is equal to RL parallel with small rd parallel with capital RD. So F21 corresponds to one low pass filtering action. F22 corresponds to one low pass filtering action. So we have seen that how to compute F2 from an operation. Okay. F2 is equal to F minimum of those things. We have seen that. So this is mid-frequency analysis and high-frequency analysis of the RC coupled amplifier. We'll see in the next session the low frequency analysis. Thank you.